Raspberry Pi and ESP boards, whereby we have ESP32 and ESP8266. So today we are going to, for the next 5 days from today to Friday, we are going to dive into MicroPython, which is a new language compared to other languages like Arduino and C++. So as you know, MicroPython is usually it's written in it's under Python actually, but we're going to learn MicroPython. Then the boards which we are going to use are Raspberry Pi. We have a different variety of Raspberry Pi boards, but basically we are going to interact with Raspberry Pi Pico. So sorry for, I think my computer was not able to join the main meeting. I think you can, if you can see my screen, maybe you can, Alex, can you confirm if you can see my screen? Okay, let's start. Okay. Yeah. So for you to learn MicroPython or to learn robotics and embedded systems, you need to know which programming languages do you need to learn. Also, you need to know the basics, because in everything you have to start from the basics. I'm assuming we have totally beginners here. We have those people who don't have any knowledge of in programming, either in also circuits and okay, the physics knowledge. So we are going to start with the basic electricity, whereby we will have to know how do we get the voltage, how is the electricity being produced, what voltage does the board use, and the specification of the board. Okay, I think several people might have known about Arduino. Arduino is another microcontroller. Actually, it's very famous compared to Raspberry Pi Pico. So the slides which I have for the introduction part for Arduino, but we're going to relate with the Raspberry Pi Pico. So basic electricity, we are going to learn how is electricity being produced, stepping up, stepping down, and until it reaches to the end user. Okay, the key concepts, number one, you need to understand what is voltage, current, and resistance, because if you are going to interact with the boards, for example, the Raspberry Pi Pico and the sensors, we are going to need the resistors so that we can protect the devices. Also, we are going to maybe learn about what is Ohm's law. Yeah, so there's a code there. So as you know, electricity, there's a man called Michael Faraday. Actually, he's called the father of electricity. Without him, we could not have electricity. He discovered several principles on dynamo principles. Okay, now in introduction, we get basic electronics components. You need to understand the several basic electronics components. We have a resistor, we have a switch, we have LDR, light dependent resistor, from this image, and we have some bulb and transistor or MOSFET. We have a potentiometer and a capacitor. So you need to understand some basic electronics components, but not all, because you can build on top of the knowledge which you learn day in, day out. Also, you need to understand what circuits, electronic circuits. Actually, the basic most thing you need to understand with circuits, you don't need to understand anything that is complicated about the circuits. You need to understand the open and closed circuits. Okay, then circuit design. How can you design a circuit? You're going to learn about something called a breadboard. Actually, for a beginner, you need to understand well breadboard, because that is it's another name for breadboard. It's called a prototyping board, whereby if you are building a circuit, you just need to simulate it on the breadboard. Then after simulating in the breadboard, you can now solder in the PCB or maybe puff board. This is called puff board. You can also design a PCB, but for beginner, we need to understand what is a breadboard. We are going to dive into that. Okay, definition. Okay, cells. You need to understand the cells and simple circuit. This picture, you can see we have two diagrams. Diagram number one, we can see we have a cell. It's a dry cell, and we have a bulb. Also, we have some wires. Those are connecting wires. So with that, the type of circuits we have, what type of circuit we have? We have a closed circuit. That is called a closed circuit. Okay. This one, the first diagram, it's called a schematic diagram, and the second one, it's called a circuit diagram. So you need to understand the difference between schematic and circuit diagram. Okay. Okay, these are simple representation of a closed circuit, whereby we have a power source. For example, power source can either be AC or DC. So you need to understand what is the difference between AC and DC. AC is called alternating current, and DC it's called direct current. So the difference in a layman language, the difference between AC and DC is just very simple, because DC we have only two terminals or two polarities, which are positive and negative. Unlike in AC we have three, but two are major or are common. We have neutral, we have earth, and live. So in alternating current, they usually alternate between the positive and negative. We cannot say the live is positive or negative, because they usually alternate. Actually, they usually alternate 25 million times in 1 second. So as you can see, we have protective device here. It's a fuse, and this is a control device. I'll come back to the control device. We have the conductor. The conductor can be anything that can transmit electricity. Actually, conductors we have good conductors and bad conductors according to science. But this one should be a good conductor of electricity. Then anything that is connected to electricity is usually called a load. So this is load 1 and this is load 2. So another approach we are getting here, we have a type of connection. So these two loads, which are bulbs, are connected in series. So we have series and parallel. But what I need you to know, I just need you to know the basic most approaches in circuits, whereby you just need to know the difference between open and closed circuit. Actually, this is a control device. For instance, we have this is a switch. It can open the circuit and close the circuit. Is there any question up there? I think if there is any question, Alex, you can interrupt me, and maybe I'll answer. So the control device, it's for instance, we are using a switch, but now let's assume we want to automate the process of controlling the bulbs or the loads, because we are imagining the loads are not only the bulbs, They can either be, let's say it's a computer, let's say it's a fridge, a TV, it's a, let's say anything that can consume electricity, it's called load, electrical load. So let's say we want to control it from anywhere in the world. So these control device we are going to use, we are now going to replace the switch with a microcontroller. For instance, we're going to use a Raspberry Pi, but we have different types of microcontrollers. We have Arduino microcontroller, a Raspberry Pi. We have ESP boards, which are also microcontrollers. Next, this is also the difference between two circuits, which are the major circuits. Number one, we have open circuit and we have closed circuit. So I think you can note the difference. Okay, let me ask, which is the closed circuit between the two? The first one or the second one? Someone can just shout the answer. Which is the open and closed circuit? Anyone? Any? Yeah. The first one is open circuit. Yes. It's closed. Yeah, it's closed circuit. Yes, but the second one, it's open circuit. Actually, the electricity will not flow from. Okay, electricity current usually flows from positive towards the negative, but now it will flow towards the negative, but through a load, electrical load, which, for instance, we have the bulb. Okay, so this bulb will light, but this one will not light because we have some break here. Okay. Short circuit. Actually, you need to know what is short circuit. Short circuit. Let me read that. A short circuit is it's like giving electricity a shortcut. Actually, just understand that. And we have effects of short circuit. Like for example, it can cause fire, as you can see in the diagram. Also, it can also what else? It can cause fire. Also, it can heat up the circuit. Yeah, those are actually short circuit is usually negative. If you can avoid, don't short circuit the wire. Actually, short circuit we said it's like giving electricity a shortcut. One form of short circuiting is connecting positive terminal to the negative terminal directly without passing through a load, electrical load. Actually, there's another form of short circuiting, which is using a, okay, let's say we have a bulb which is rated 5 volts, and the power supply is around 250 volts. If we connect the 5 volts bulb to 250 volts, actually that could be called a short circuit, but necessarily we don't have to connect the positive directly to negative so that we can say we have achieved short circuiting. Actually, if you connect the same applies with the microcontrollers. If you connect the positive, which is the VCC, to ground, you can even destroy your board, which is the microcontroller. So you should avoid connecting the positive towards the negative, even if it's accidental. Okay, these are simple circuits for illustrating short circuits. Also, you need to understand voltage in electrical systems, but I'm not going to dive into this. You need to understand voltage, current, and resistance. That is called Ohm's law. Okay, I think now we are good to go. We are good to go to start MicroPython. Okay, basic. Okay, these are Arduino. Okay, you can use Arduino components on Raspberry Pi. Actually, they are much related, but we are going to use a microcontroller. In robotics, we have three major dimensions of robotics. Number one, we have a microcontroller. For us, we are going to use a Raspberry Pi Pico. Number two, we have sensors, and we have sensors. Like for example, we have. Can you name some types of sensors in the chat? You can also, yeah. Which type of sensors do you know? Then Alex, you're going to read for me. Which types of sensors do you have? Everyone should name at least one sensor, one type of sensor. Ultrasonic sensor. Yes, Albert Moy. Which other type of sensor do we have? Which other type of sensors do we have?
Oh, we have some on the charts here. Water sensors,
yes,
humidity sensors, soil moisture sensor, ultrasonic sensor, and also motion sensor.
Motion sensor, sure. Almost everything you can feel or you can see, or we have a sensor for it. Let's say, is it temperature? Is it light intensity? Is it be it moisture? We have a moisture sensor. So almost anything you can sense, you can feel with your body, we have a sensor for it. Now, if you are building a system or an embedded system, we are going to utilize the sensors. So to our system. So the sensor will collect data, then send the raw data, which is not processed, the raw data to the microcontroller. Now, according to our code in the microcontroller, we are going to, according to the code in the microcontroller, it will now run a script and also control some devices. Like, for example, the other dimension in robotics, we have actuators. Now, actuators are like switches and motors. Actually, we have only two major. Okay, maybe we have others, but the major actuators, we have motors and actuators. So let's say we want to switch on light using our phone from anywhere in the world. We are going to utilize the actuators because we cannot connect the microcontroller, which is rated at 5 volts, directly to electricity, which is rated at 250. In fact, now electricity is AC, and the microcontroller is now running at on DC, direct current. So we have a huge difference between the two. So we are going now to utilize the the actuators. Is there any question? If we have any question, you can interrupt me. So the next thing we need to know, we need to learn about breadboard and wires. So I told you as a beginner, you must understand the breadboard.
So, what are some of
the breadboard? You need to understand the breadboard, the working of breadboard, and the orientation of the breadboard, the pins. And also you need to understand the different types of wires we have. Actually, we call them the jumper wires. We have three major types of jumper wires. Number one, we have male to male jumper wires. We have male to female, and we have I said male to female, and we have female to female. Actually, in the case of breadboard, the most used type of wires or jumper wires are male to male. But also you can use male to female, but mostly we use male to male, and rarely we use female to female. Okay. Next, there's types of sensors. here are the types of sensors. We have number one. Can anyone name any sensor they can see there? Let me see. Which sensor can you note there? Type in the chat. We have different types of sensors here. Anyone?
Okay, there are some answers in the chats. Ultrasonic sensors and water sensor, gas sensor, DHT sensor, and a flame sensor, and also ultrasonic. And there's also a question.
Yeah.
Explain how you control your microcontroller remotely.
Okay, it's a nice question. Okay, before I come to that question, I can just name randomly the sensors. From here, maybe we have this is a gas sensor. It can sense. Okay, not really. This is a smoke sensor. This is a smoke sensor. Also, I think it can also measure or monitor gas. But this one, yeah, this one is an it's a alcohol sensor. It can sense alcohol and also air quality. We have this one is a temperature sensor. It's called this one is called MQ3, MQ7. This is called LM35. These are temperature and humidity sensor in one. It's called DHT11. It's a flame sensor, water level sensor, a vibration sensor. These are light sensor, ultrasonic sensor. I already named that. This one it's called a PIR motion sensor. Actually, this one, the application of this one, it's for the motion of operated lights or motion activated lights. We have this one. It's called a microphone. It is a microphone, but it can sense sound. Actually, it's called sound sensor. We have RTC. If you are building a project and you need to monitor the time, let's say it's an attendance system. Maybe you want to monitor at what time did these employee check in. You're going to use RTC. Actually, it has a battery slot here. It has a battery slot here. This is called laser sensor. Okay, just to name but a few. And these two are actuators. I told you actuators. The major ones we have relay and motor. Actually, these are DC motor. Actually, we cannot connect the DC motor directly to. Actually, I'm answering that question. We cannot control a DC motor directly from the microcontroller. We have to connect it through either through a relay or through a transistor. Okay, because the reason behind that it's because the DC motor usually draws a lot of current, which a microcontroller cannot provide, and if it will provide, it will maybe it will be destroyed. Okay, it will not maybe be enough. Okay, I think we are done because that was the introduction part. Let me answer that question. If you want to control, let's say your light from anywhere in the world, how do we connect the light? We usually connect it through a relay to the microcontroller board. Let's say we are using a Raspberry Pi Pico. So we connect the Pico to the microcontroller. Then after there, okay, the Pico to the relay. Then from the relay, we are going to connect the load. For example, it's light, AC, or a pump. Let's say it's an you're designing a smart irrigation system. So you're going to connect the pump, which is AC, to the relay, then the relay to the microcontroller. Actually, you know, how do we control the relay? We are going to control the relay using low voltage to control high voltage. Yeah, I think. Then for the connection between your phone and the the hardware, it's very simple. We have several, I think we have so many ways we can connect them, and each way has their own advantages and disadvantages. Number one, we can connect them through Bluetooth, but we know the problem with Bluetooth. Actually, the problem with the Bluetooth connection is the range. We can also connect them via RF, radio frequency, and maybe, okay, for Bluetooth, you can control up to 15 meters LOS, line of sight, and for RF, you can now control up to, I think, 100 kilometers away. And we have GSM. I think you know GSM. Someone can type the full meaning of GSM. For GSM, we can control from anywhere in the world as long as you have credit or balance in your, maybe you have subscribed to some plans. Also, you can also control from anywhere in the world. Okay, for GSM, you can also control it from anywhere in the world. But now, through internet, called Internet of Things, you can control from anywhere in the world. Now we are going to utilize the internet. So the board must be enabled, must be connected to your local area network or maybe Wi-Fi. Then it will expose the connection and the code online. Now you can, a client, let's say client like me, okay, my phone will connect to internet, will be connected to internet. Let's say, for example, I'm in another country, like like Canada. I connect my phone to the internet. Now I can access, I can monitor, I can see this light is on. Maybe I can turn it off. Yes, I think I've answered that question. Is there? Are we good? Can we continue?
Yes, so far I think everything is great. Unless anyone has a question, you can just type it in the chat or raise your hand.
Okay, let me head to, I need now to start the Raspberry Pi programming. So number one, we are going to let me reshare again. Just a minute. So I want to open the Raspberry Pi slides or the learning material. So actually, let's see how many have ever interacted with MicroPython, maybe, sorry, or any programming language. And maybe you can name the programming language in the chat. Someone, everyone, anyone who has ever interacted with any programming language, kindly type it in the chat as we get the. And which one did you interact with?
Okay.
Is there any response?
From the charts, I see there is C++ and also basics on Python.
Basics on Python.
And also web scripting languages like React.js.
Okay. So before you learn any programming language, you need to understand why are you learning it and how are you going to apply it. Actually, I usually hear some people telling me I'm proficient in in Java. Can I code robotics? I think you can see my screen. Okay. Yeah. So for you to learn robotics, you need to understand which programming languages we use in robotics. Like for example, in robotics, we usually use three major languages. You can learn C++, you can learn C, you can learn also Python, and I heard there's another language. Actually, I'm planning to learn that language. It's called MicroPython. Sorry, it's called Rust. It is usually used for programming also, programming of robotics. So let's head directly to Raspberry Pi Pico programming and have a look at Raspberry Pi. So number one, let me open this image. I think I'll have to share the whole screen, the entire screen. Sorry for that, entire screen. So this is the Raspberry Pi board. I'm trying to open. So number one, you need to understand specifications of Raspberry Pi. I don't know why I'm getting Raspberry Pi Pico specifications. So what are the specifications of Raspberry Pi? Okay, number one, the size of Raspberry Pi. The size is 21. So let's see. Here was that. Yeah. So which site is this? It's raspberrypi.com. Actually, if you head to raspberrypi.com, you're going to get this information. So number one, you need to understand the size. Actually, if you are designing, let's say it's a PCB, you need to understand the sizing, so that you can include in your PCB design. It's very critical. Also, you need to understand the type of chip which it uses. It uses RP2040 microcontroller chip. Actually, in Arduino uses Atmega 328P. It's dual core Cortex, that is the processor, and the clock speed is 133 megahertz. Okay, most of the specification here, you don't need to understand them, but there are several others. Okay, we have a wireless connection. It can connect to LAN, local area network, and it will operate at 2.4 gigahertz. That is the band which it will operate in, the same band for Wi-Fi, wireless fidelity. And for this one, this specification is for Raspberry Pi Pico W and Raspberry Pi Pico WH only. Okay, we have, let me, you don't be confused with the following terms. We have under Raspberry Pi Pico, we have different types of boards. Number one, we have Raspberry Pi Pico. Number two, we have Raspberry Pi Pico W. Number three, we have Raspberry Pi Pico WH. So maybe I'll try and see if I can get the difference between the Raspberry Pi Pico, those three boards. But basically, Raspberry Pi Pico, it's just the simple Raspberry Pi. It cannot connect to Wi-Fi, but can do anything that the rest of it cannot connect to Wi-Fi and Bluetooth, but the rest of the boards can do that. Also, it can do the rest of the tasks which the other two boards can do. Then we have Bluetooth 5.2. Actually, this is which version of Bluetooth are you using in your phone? Actually, this looks like the latest one, 5.2, which is available only on Raspberry Pi Pico W and Raspberry Pi Pico WH. Samsung. Those two boards have Wi-Fi connection and they have Bluetooth connection. No, this is not just the normal type, normal Bluetooth, but it's BLE. BLE stands for Bluetooth Low Energy. Okay, next, it has 26 multifunctional GPIO pins. GPIO stands for General Purpose Input Output Pins. Whereby those pins can either be inputs and they can also be output pins, depending on your code. So you have to declare in your code in the first phase, whereby when you are defining and declaring, you have to declare them as either inputs or output pins. It has 3 analog inputs. Okay. 2 UART interface. Actually, these are the modes of communication with the other boards. UART, it has SPI connection controllers. You can connect it through SPI. It has I2C. Actually, for other devices like LCD, you have to connect them through I2C. It has 16 pulse width modulation channels. What is pulse width modulation? Actually, with pulse width modulation, it means you can control this. Let's say you want to connect to. Okay, these are GPL pins, but they are special GPL pins. In that, they can be plotted between the range of 0 to 255. They can whereby 0 means 0 volts and 255 means 5 volts. So if you and 2.5, what is the half of 255? It's around 1.7, if I'm not wrong. It's around 2.5 volts. So if you want to control the speed of motor, you have to connect not to any digital pin, or sorry, not to any GPIO pins, but to PWM enabled pins. Also, it has one USB, that port 1.1, that is the size. I don't understand what PHY means with host and device support. So you don't have to understand everything, but the basics. It has 8 programmable I/O pin, state machines for custom peripheral support. It supports input voltage of around 1.8 volts to 5.5 volts DC. Actually, this point is usually very important, because if you power the board with more than 5 volts, it will fry up the board, and you don't need to do that, because they are a bit expensive. So you have to power it from this range, 1.5 to 5.5 DC. Also, you have to make sure it's DC. Even if you power with 1.8 volts and it's AC, it's still going to destroy your board. Operating temperature, also, it's negative 20 degrees Celsius to plus 85 or to 85 degrees Celsius for Raspberry Pi Pico and Pico H. And now for the rest of the boards, which is Pico W and Pico WH, it's negative 20 to positive 70 degrees Celsius. Castellated module allows soldering direct to carrier boards. Okay, for that one, I'm going to show you. You can also solder the mail headers to the board. It can support drag and drop programming using mass storage over USB. Actually, for kids, is there anyone proficient in Scratch programming languages? For kids, they usually code it Scratch. So for microcontroller, which is a Raspberry Pi, you can also code in drag and drop. That is Scratch programming language. Okay, low power sleep, which is a dormant mode. Yeah, you can put the Raspberry Pi into sleep mode. We have different types of sleep mode. We have deep sleep, we have active state, and we have dormant mode. Yeah. So for that, if you like your phone, if you don't use your phone for let's say 5 minutes, it will sleep, but doesn't mean that it will it will it will turn off, but it will just sleep. So that is the sleep mode, and it will not consume a lot of power. Okay, accurate on-chip clock. It has onboard clock, on-chip clock, RTC. Real-time clock. It has these two types of sensors, which we can use in the next class. It has onboard temperature sensor. Actually, you can measure temperature using the Raspberry Pi Pico through the inbuilt temperature sensor. It has accelerated integer and floating point libraries on chip. I don't know what is that. Also, it has another sensor. I don't know why they have not included in these specifications. It has accelerometer, which can sense the orientation of the board. Yeah. Is there any question before I move ahead? Any question?
There's a question on the chat. What programming language can I use with a Raspberry?
Yeah, I think I mentioned that you can actually Raspberry Pi Pico. You can program in different types of languages. You can program it in Python. You can program it in MicroPython, in CircuitPython, and in C and C++. Okay, but not directly in C and C++, but through a programming language which is called Arduino programming language, which is comprised of, or it's made of, it's made using two programming languages, which are C and C++. I think I've answered that, but actually, I think it's usually designed to be coded in MicroPython. Also, you can code it in Scratch. I think I mentioned that before. Okay, so if you want to learn more about the Raspberry Pi Pico, you can head to this official documentation, maybe here, and go to getting started. Raspberry Pi. Okay, we have also other types of Raspberry Pi. Actually, this is the Raspberry Pi board B+, which is it's a computer itself. You can use it as a server and also as a computer. Yes, actually, I used to use this one as my laptop. I used to carry it. Then I just connect the projector and a wireless keyboard, and I use it to project during my classes as my computer. It has several ports. Here we have, let me see if I can get a clear picture. It has Raspberry Pi 5, not Pico, but Raspberry Pi 5. Let me see if I can get a clear picture. You can see the RAM of this Raspberry Pi, it's 8 GB. You can get 2 GB, you can get 4 GB, and even I don't know if we have 16 GB, but yeah. So image. So as you can see, I think the image is not really clear, but it has four USB ports whereby you can connect your USB devices like keyboard, mouse, and maybe flash disk. It has an Ethernet port whereby you can connect your Ethernet cable, and it has some power pins. It has a mini HDMI. As you can see, this is HDMI, and the GPIO pins. Let me find another image. I don't know why I can't. Yeah, as you can see in this image, we get it has these two mini HDMI and power. You can power it using 5 volts, using the Type C cable, and also we have these four were USB cables, ports, sorry, female, and Ethernet. You can use this one as a server. Let's say you are deploying a project, an IoT project in your farm. You don't need to use your laptop as a server. You just need to deploy this Raspberry Pi machine as the server. Also, let me maybe I can share a project you can actually do with it, and maybe you start earning. You can try and design Piso. There's a Wi-Fi vending machine called Piso. Actually, it's open source. Maybe you can go and search for it. Yes. So let me, on my side, I get some questions from Tukotu. Yes, Flipper Zero available. Yes, but that one is for hacking. Today we are not going to cover that. We have yes, Raspberry Pi is a mini. Actually, it's a mini computer. It's a microprocessor because we have two types of things. We have a microprocessor and microcontroller. Actually, you can use this Raspberry Pi to code. Yeah, you can even install Linux on it. You can also install Kali Linux, VS Code. Those are okay. Kali Linux operating system. We have another called Raspbian OS. I used to also Ubuntu. I used to operate it in Raspbian OS. So, and also install those other applications. Okay, away from that, I think. But the board which we are getting started with, it's called Raspberry Pi Pico. So let me see if we can get. Is there any question? Okay. So number one, we can go to getting started with Raspberry Pi Pico. You can either use this site or maybe use the PDF. I'm going to share the PDF on your emails. So make sure I have your emails. So introduction to Raspberry Pi Pico. Introduction. In this project, you're going to connect Pico to another computer and learn how to program it using MicroPython. Actually, MicroPython is very interesting and it's a very easy language to learn if you know the syntax of any programming language, because it's built on Python. Okay. Let me read the introduction part. A Raspberry Pi Pico is a low-cost microcontroller device. The microcontrollers are tiny computers, but they tend to lack large volumes of storage and peripheral devices that you could plug in, for example, keyboards and monitors. So you see now the difference between microcontroller and microprocessors. We see they tend to lack what large volumes and peripheral devices. Actually, the difference between these one, the microprocessors now, like a Raspberry Pi Pico, the board which I show earlier projected here, it has a high storage volume compared to microcontrollers. For example, you can get it at 8 GB RAM. Also, it can have you can customize the ROM by using a flash. Let's say it's a flash of 128 GB, 64 GB, 32 GB, and also you can connect an SD card whereby you are going to burn the program or the operating system. Let me see if I can get SD card, an image. Yeah, nice. You see this image is showcasing how you can insert the SD card. I think you can see my screen. Sure. Yeah, you can see this SD card. It has the operating system. Also, another thing which I forgot to tell you, it has a jack, headphone jack, audio jack. Okay, let's continue. Yeah, Raspberry Pi Pico has GPIO pins, which are general purpose input-output pins, much like a Raspberry Pi computer, which means it can be used to control and receive input from a variety of electronic devices like sensors, buttons, yeah, also wireless modules. Okay, let's continue. So number one, what are we going to make maybe in the next class? We are going to, in programming, which is the first code which you learned? Someone type there below. Which is the first code which you learned in the first programming language? Or which was it called? What was it called? Let me see. Yes, yes. Let me see on my end. I can on my end I can see some question. Do you do Python in robotics? Because in CS we don't do robotics, only AI and machine learning or computer science. Yes, yes. You can do robotics in Python, but it's a bit advanced robotics, which is machine learning. Actually, you can do machine learning we do using Python. And actually you can use that board which I project. These are, do you know? Sorry, these are Raspberry Pi, because it has a camera module. You can use the camera for detecting the images and maybe classifying the images. Yes, and in AI we have something called the edge impacts. Maybe you need to go and learn about that site. You can design your models and something called tiny ML. Yes, I think so. For Python, you can do the machine learning and AI. Okay, let's continue. Is there any question? Any question? Computer vision. Yeah, not really computer. Okay, you have computer vision. It has a different dimension. But like OpenCV, you know, OpenCV, actually, yes, OpenCV is a computer vision. We are video which I did that with computer vision. You can go and check it on my TikTok account. My TikTok account is Mr. Arduino. Mr. Arduino. Okay, Alex, is there any response on the chat? Which was the first programming language? What was it called?
I think most of the people they're answering "Hello World." I guess you meant the first thing we learned. We learned
Yes,
programming.
they are correct. Actually, they are correct. It's hello world. So in any programming language, you have to understand the hello world programming language. But if you don't understand the hello world programming language, you cannot understand anything in that language. So you have to understand because it lays down the structure of the programming language and the syntax, everything. So, but now we are not coding we are not learning programming language and okay, it's a programming language, but necessarily we are learning embedded system or robotics. So the first code which you are going to learn, it's called Blink. In embedded system and robotics, we usually do blink, whereby as you can see in my screen, that is called blink. If you cannot understand blink code, if you cannot understand anything with the microcontroller and robotics, actually you'll struggle so much because it lays down the structure and syntax. Actually, something you need to note, all programming languages, they have the same structure but different syntax. Okay, next. What you'll need, I don't know if everyone can afford to purchase the components, but if you need the components, I'm going to give out my number. I can source for you. They're not very expensive. Actually, they're not so expensive because even the Raspberry Pi Pico, I think it's around 800 shillings. Okay, you just need the Raspberry Pi Pico with soldered headers. You can also solder for yourself a computer that can run Doni IDE. Oh, nice. So the next thing we need to understand the type of ID we are going to use. We are not going to use VS Code, or which we can use VS Code in the. We can use VS Code. We can use Arduino IDE and another platform called Platform IO. If you know Platform IO, I know several people know Platform IO, but Doni, it's a nice IDE and light one. I'm going to show you. And also, you are going to need a micro USB Type B cable. Then what else? A selection of electronics components such as button, LED, and resistor and the potentiometer, optional. But if you got the Raspberry Pi Pico and USB cable with a budget of let's say it's around 900 or 1000, you can get these. You're good to go. Actually, we are going to work with the minimum budget and the minimum components which we can avail. Also, you are going to need an LED. LED stands for, type there below. LED stands for LED stands for long. What does LED stand for? Okay, yeah. Here I got some response, encrypted coder. Yeah, what does LED stand for? Alex, is there any response?
Yeah, there's some responses. Light emitting diode.
Yes, true. LED stands for light emitting diode. And what is the opposite of light emitting diode? Anyone? What is the opposite? Which is the other component for now? It will not emit, but it will depend on that light. What is it called? It's through encrypted code. You're correct. Yes. Anything. So also we are going to need a breadboard. I'm going to show you what is a breadboard. We are going to need a breadboard. This is a breadboard. You can see we have this one. Let me show you. This is a breadboard. This is a breadboard. You need okay, this is a mini breadboard, but you can buy the full breadboard. Yes, and also you need to understand the working of the breadboard. Actually, if you don't understand the working of the breadboard, also you are doomed. You are not going to do anything that is of any value because you can even do short circuiting using the breadboard unknowingly. So you must know the breadboard in and out. Okay, next what we are going to need, we are going to need an external 5 volts USB power source, which is optional. I think you don't need it for now, but if you are serious about venturing into robotics and microcontroller or embedded system, you are going to need the 5 volts micro USB power source. Okay. What is the opposite of LED? Anyone? Okay, the opposite of LED, it's a LDR, light dependent resistor. It's a resistor which will depend on light and it will act accordingly. Okay, next, the software we shall need, the project, okay, the software which we shall need Tony IDE. I'm going to show you how Tony IDE looks like, and MicroPython firmware for Raspberry Pi Pico. Is there any question? If you have any question, because we are coming to the end of our session, so in the next few minutes we are going to end and maybe open Q&A session. How to load the MicroPython firmware onto Arduino? Sorry, I'm used to Arduino, onto Raspberry Pi Pico. So actually, you cannot buy Raspberry Pi Pico and directly start programming it. You have to prepare it, and you have now to load the firmware. And it's a process. Actually, you need to understand that process. Yes, how to program Raspberry Pi Pico using MicroPython, how to connect additional components to Raspberry Pi Pico, like LEDs and sensors. Yes, and additional information for educators. I think now you are not educators, so I'm not going to show you there. So is there any question?
There's a question on the chat. Can you specialize in machine learning and AI without data science and then build intelligent systems?
Can you specialize in machine learning and AI?
Without data science and then build intelligent.
I don't think, okay, data science, like the course, I don't understand, but for machine learning and AI, you need to understand data. You need to, okay, you need to interact with data, because for you to train a model, you have to train the model using data. Actually, you need to, they call it data sets. So you train the model as many times as possible to make it accurate now, and then you are going to test it. So you need to learn something to do with data, but necessarily you don't need to learn data science, but you have to understand the data and some algorithm. What was Abu, read again the question?
Can you specialize in machine learning and AI without data science and then build intelligent systems?
I think it's not possible. You need to be a master at data science, and then after that, you'll build those intelligent systems. But good news is you can start small. You can start some site, like we have a site called Edge Impulse. I think you can see my screen even. I wanted to write in the comment, but it's called Edge. Sorry, let me write here. Edge Impulse. Whereby now for Edge Impulse, now you're going to train some models based on hardware. Go there and learn more about Edge Impulse. It's very simple and it's free. charge. Yes. Is there any question? Any other question before we call it a day? Even on TikTok, we also. Where someone is asking me, where can we buy the components locally? Actually, locally you can get the components. Let me see. Yeah. Okay, we have this site called IV Liam Gadgets Limited. I'm going to share the link. I think Alex, you're going to share to the main group. So where was it? Yes, here you can get the prices of Raspberry Pi. So what I need you to buy, if you are going to buy, you can go and buy the Raspberry Pi Pico, which costs 750. I think that is very cheap, 750 shillings. Then we are going to continue with the session. Okay, any other question? Any other question?
Okay, we have two questions on the chat. So what items do I need to buy to get started with the Raspberry?
Okay, the items. Let me show you the items. Okay, you can buy a starter kit. We have something called starter kits. Let me see if we can get one. You see this one, it's called a custom kit for Raspberry Pi Foundation Pathway. You can buy this, you can purchase this one. It has a breadboard, LEDs, it has resistors, many of them, it has male to male, male to female, female to female, male to male, male to female, female to female, yeah, jumper wires, breadboard. What you just need to add here, you just need to add the Raspberry Pi Pico, which is 750. So with a budget of around 3,750, you can get that starter kit. Also, we have these other basic starter kit, but this one it goes for 2,000 shillings. Actually, they can recommend you to buy this one. Okay, but this one it doesn't have any sensor. But for this one, we have the sensors, but also you can buy them in separate. Yeah. If you buy this one, you can now add some sensors in separate. So you can go to that link and explore more options. If you are stranded, you can text me on WhatsApp. I think everyone has my number. Yes. Any other question?
There's one more question here. Okay, do you know the field for building or feeding an AI chatbot?
Do you know?
The field for building or feeding an AI chatbot. Chatbot.
Chatbot. Yeah, okay. Unfortunately, I'm not more into AI, and actually, I'm learning AI, but I think that is beyond my capacity. Let me not lie. Next one.
Yeah, also people are requesting you share the slides and the slides
Slide.
which you used, yeah.
Okay, no problem. I'm going to share the slides. The slides, I can share a link. Let me see if I can share. Yeah, is there any other question? Because we need to end. I think on my side, let me see. Where can we buy the components locally? I think I should. Can you get me Flipper Zero? If yes, how much? It's very expensive. I'm going to see if I can get you one. Can you install a server? Actually, you can install the server in that. You can use it as a server. The Raspberry Pi Pico. Sorry, the Raspberry Pi board. Let me see. I don't have any other question on the side. In way to collaborate. Copy link. Edit. Let me see if you can. I can share the link. I don't know how if they will have the access to edit, but if it has access to edit, don't delete the slides or tamper with them. Yeah. Can you have one Pico as a master processor and it links to other? Sure, you can. Actually, there's a part whereby we were learning about we were learning about the specifications of Raspberry Pi Pico. We saw we have different types of communication modes. One is UART. So with that connection, also we have SPI. You can set one Pico as master and the other as slave. So the master will be commanding the slave, and they will be communicating throughout. Okay. Any other question? I think here we have no other question. Let me show you the Dhoni. In next class, I need you to, which is tomorrow, I need you to download the Dhoni IDE and install it. So this is Dhoni and this is MicroPython. We are going to learn about this MicroPython code. So you can go and learn about the basics of MicroPython and install Dhoni IDE. It's free. It's free. I think you know where to download. Just search Dhoni IDE, download. Then you are going to see how you can get this. Any other question? Any other quiz? Okay, having no other question, I think it's time for me to end the meeting on my side. So, thank you for your time. You can also interact with me. My number, I think, from the forms we have my number. You'll get my number from the forms. Yes. So I'm going to send. Okay, it's okay. Let's meet tomorrow. But make sure you install the Raspberry Pi Pico. Sorry, the my Dhoni IDE. Then we are going to. Sorry. Tomorrow we are going to start. Tomorrow we are going to start on programming the Raspberry Pi Pico. Okay, thank you for your time. If you need, if you need to purchase the Raspberry Pi Pico board, you can get in touch with my number. I can see how I can organize for some. Yes. Thank you.
Yeah, thank you so much, Fred, for that session. Yeah, I guess we'll pick it from there tomorrow and get a bit practical. So I think we'll try to solve the technical issues. If it won't be possible, we'll just use Google Meet. Yeah, but everything will be communicated in the emails. Yeah, thank you all for joining and have a good night.